Imagine a pendulum swinging back and forth. Now, what if we tell you that the pendulum's behavior isn't as predictable as you think? Picture a simple pendulum, a weight suspended from a pivot, free to swing back and forth. It might seem straightforward, but even this simple system has its surprises. You probably expect it to swing back and forth in a predictable pattern, right? Well, that's only part of the story. Enter the double pendulum, a pendulum with another pendulum attached to its end. Suddenly, the predictable becomes unpredictable. The regular becomes chaotic. The motion of this double pendulum is a spectacle of classical mechanics, a dance of order and chaos. This is the magic of classical mechanics. It lets us peer into the intricate ballet of objects in motion, revealing the underlying forces and laws at play. It helps us understand these seemingly unpredictable systems. So, the next time you see a pendulum, remember, there's more than meets the eye thanks to classical mechanics. Ever wondered why you lean while taking a sharp turn on your bike? Classical mechanics has the answer. When you're cycling and decide to make a quick turn, you naturally lean into the curve. This isn't just because it feels right, but because of a concept called centrifugal force. Centrifugal force is a type of inertial force that acts on a body moving in a circular path and is directed away from the center around which the body is moving. Speaking of inertia, it's that same principle that makes you jerk forward when a car suddenly stops. Inertia is basically the resistance of any physical object to a change in its state of motion. It's why you're pushed back into your seat when a vehicle accelerates, and why you lurch forward when it comes to a sudden stop. So, while you might not realize it, you're experiencing classical mechanics every day. Did you know that Sir Isaac Newton was only 23 when he formulated his laws of motion? Quite a feat, isn't it? Newton, a vibrant young mind, gave us the 3 laws of motion that form the backbone of classical mechanics. His laws showed us how objects move and why they move the way they do. And then, there's Galileo Galilei. Before Newton, Galileo was the one who kick-started the study of motion. He was the first to argue that a body in motion will remain in motion unless acted upon by an external force, a concept so fundamental, it later became Newton's first law of motion. The contributions of these 2 giants laid the groundwork for understanding our world and the universe beyond. Their principles of motion and gravity are the very reasons why we can predict the movement of stars, build skyscrapers, and even play football. These historical figures didn't just write the rules of the game, they changed how we play it. How can we see something we can't see, with a little help from classical mechanics? Now let's delve into the realm of the unseen. Imagine an apple falling from a tree. Though we can't physically see it, there's a force at play here: gravity. It's this invisible pull that brings the apple down to the earth. Now let's consider a car screeching to a sudden halt. What keeps you lurching forward even when the car has stopped? That's inertia, another unseen yet powerful force. It's the resistance of any physical object to a change in its state of motion. In both instances, we can't directly see the forces in action, but we can visualize them through their effects. It's like seeing the wind through the rustling leaves. We can't see the wind, but we can see what it does. While we can't see forces, we can see their effects, and that's what makes classical mechanics so fascinating. Classical mechanics has shaped our world, but there's much more to explore. It's a field that's robust, reliable, and yet it has its limitations. For instance, classical mechanics falls short when dealing with phenomena at the atomic and subatomic level. It's here that the weird and wonderful world of quantum mechanics comes into play. Quantum mechanics, with its particles existing in multiple states simultaneously and behaving both as particles and waves, is like Alice's wonderland of the physics world. It's a realm where our everyday logic is turned on its head, and yet it manages to explain phenomena that classical mechanics cannot. In the upcoming videos, we'll be diving into this fascinating field. We'll explore the dual nature of light, the uncertainty principle, and much more. So, stay tuned as we delve deeper into the intriguing world of quantum mechanics in our upcoming videos. Don't forget to like, comment, and subscribe to join us on this exciting journey.